Hey everyone, in today's video we're going to be looking at predicting the number of real roots of a quadratic using something called the discriminant. So we know if we have a graph of a quadratic that we can look at the x-intercepts, also known as roots, zeros, and solutions, and we can see very clearly that there are two of those in this equation. This equation here goes with the graph. And so we can see that this equation is going to have two real roots. So what we're going to be doing is we're going to be focusing on how do we take just this equation right here without the graph and predict how many real roots there are going to be in the quadratic. So to review, there are three situations that we can have. We could have a quadratic that has two roots, that is two x-intercepts like there and there. It could have one root if the vertex lies on the x-axis, or it may not touch the x-axis at all, in which case we say it has no real roots. Remember, that is very important that we say real, because it doesn't have, or it does in fact have, what are called imaginary roots, but not real ones. So knowing that we could have those three situations, we have one job, which is to determine which of these situations, two roots, one root, or no real roots, we have just from an equation, not from anything else. So we're not going to be looking at the graphs, just the equation. And also important that we want the equation in standard form, that is the form y equals ax squared plus bx plus c. We don't want anything on the other side of that equation from all the x's except for a y or a 0. That's going to come up later, don't forget that. And so we're going to use this thing called the discriminant. And the discriminant is just the result I get from the calculation of b squared minus 4ac. And where the b, the a, and the c are coming from is, if you'll recall, in standard form of an equation, I have, and I'll use some colors on this so we can set it aside, I'll have a coefficient of x squared, which I call a, and then I'll have a coefficient of x, so in this case negative 3, and I call that thing b, and then I'll have a constant term out here all by its onesies that we call c. So in order to calculate the discriminant, all we're doing is finding a, b, and c, and then we take b squared minus 4 times a times c, and that 4 will always be a 4. It will never be anything else. And so when we calculate this, we just get a number. So for example, in this situation, if I were to take b squared, that would be negative 3 squared minus 4 times 5 times 2. So that would give me negative 3 squared is 9. This would be minus 40. And so now I take 9 minus 40, and I would find that this number is negative 31. And so you can see the discriminant ends up being just some number, and it's just calculated from these three. And that some number that I get, this number itself, which is called the discriminant, that is going to tell me how many roots I have. If the discriminant is positive, I have two real roots. If it's 0, I have one real root, and if it's negative, I have no real roots. So I can see in this last example, my discriminant came out to be negative. It's negative 31, and so that means there are no real roots to that particular equation. So let's look at what this will look like as far as examples go. So I'm asked to find the discriminant for this equation right here. Notice that it is set equal to 0, which is very, very important. I must have either a 0 or a y on this side if I'm going to calculate the discriminant. And so the first thing I want you to do here is just figure out what a, b, and c are. So in this case, a is 3. B is positive 6, remember to take the sign in front of it, and C will be positive 8. So to find my discriminant, the discriminant is b squared minus 4ac. So b squared would be 6 squared minus 4 times a is 3, c is 8, and all we have to do now, you can literally just substitute that, or put that into your calculator exactly as is. If you want to get super fancy pants, you can actually go ahead and do this, and you would find, let's see, 3 times 8 is 24, times 4 would sure be a number. Let's see, that would be 96. So minus 96, and put them together, and you get minus 60 for your discriminant. So I've done the first part, find the discriminant. The discriminant is negative 60, and determine the number of roots. Well, if that number is negative, and that means I will have no real roots. You could also say no real solutions. Either one is just fine. But notice I'm just using b squared minus 4ac, put it in, find the number. So let's look at another example. Here I've got 0 equals 8x squared minus 8x plus 2. I'm finding the discriminant, determining the number of roots, and I'm equal to 0, so all is set up well. A is going to be 8. B is going to be negative 8 in this case. Notice we take the sign that's in front of it. C is going to be positive 2. And now to find the discriminant, it's just b squared minus 4ac. B squared would be negative 8 squared minus 4 times a is 8 and c is 2. So again, you can just crunch that directly into your calculator, or you can go ahead and do it piecewise. Negative 8 squared is 64. Negative 4 times 8 times 2 is negative 64. 64 minus 64 is 0. So I found my discriminant. The discriminant is 0, and that tells me something about the roots, that there is going to be one real root. So just by finding the discriminant of this, even though I don't know anything about the root, I know that there is one root that exists on this thing. So you can kind of see the usefulness of this if you're asked about the roots. Before we go and try and find them, it's useful to know if they exist. So we can use this discriminant to find out, do we have any roots that we should even be looking for? All right, let's look at example number 3. Find the discriminant, determine the number of roots. But notice we're equal to 0, so that's good. But notice this equation is missing something. If I look for a, that's the coefficient of x squared, and there's nothing there. So when x squared is present, but there's no coefficient, that means the coefficient is 1. Now we look for b, which is the coefficient of just x. And what you'll notice is that x is missing altogether. Let's come back to that in a second. And c is the constant term, the number by itself. So what happens when that x term is just entirely missing? It's not there at all? Well, the only way to make something disappear like that is to have its value equal to 0. And since we're multiplying some number by x, the only number you could multiply x by to make it disappear would be 0. So in this case, since that number is not there, b equals 0. And now I can calculate the discriminant just as I was doing before. B squared, well, that would be 0 squared minus 4 times a times c. And so 0 squared is 0. Negative 4 times negative 9 is going to be positive 36. So 0 plus 36 is just 36. That's my discriminant, and since it's positive, that means I will have 2 real roots. So again, if the variable is there but doesn't have a coefficient, the coefficient is 1. And if the variable is missing entirely, the coefficient is going to be 0. All right, now let's look at a situation where everything's the same direction-wise. Find the discriminant, determine the number of roots. The thing that's not the same on this is that this is not equal to 0. So before I can find the discriminant on this, I have to make this equal to 0. So I'm going to copy down my equation to show you what we do here. And all you got to do is cast your memory back all the way to Module 1, where we were moving things around from one side of the equation to the other. I want to get rid of this 6 over here, so I'm going to subtract 6 from both sides. Now over here, I can only subtract that 6 from something that is a like term, that has the same variable with the same exponent. And since it's a constant, I can only do that with the positive 2. So over here, I'm going to end up with x squared plus 3x, and then 2 minus 6 is negative 4. And on this side, 6 minus 6 is going to be equal to 0. Now I have my equation equal to 0. I can find a, b, and c. A is 1, b is 3, and c is negative 4. And now I can calculate the discriminant just as I've been doing. B squared is going to be 3 squared minus 4 times 1 times negative 4. And when we put that all together, we get 9 plus 16, which is 25. And since that's positive, I would say I have 2 real roots. Now I've been doing this quickly, but make sure you mind your directions. The directions here tell us to find the discriminant and determine the number of roots, which is why I'm automatically doing both. Don't just reflexively do both. Check your directions and make sure you're doing what was asked. Also, remember this has to be equal to 0 before I can solve and find the discriminant. So now, for the ugliest possible case of this, we look at this one. Find the discriminant, determine the number of roots for 4x squared minus 6x minus 7 equals x minus 10. Well, now we've got like a whole variable expression over here. But we do it the same way we did the last one. We have to get this thing equal to 0 before I can do anything else. So what I'm going to do is I'm just going to take from this side over here, since my x squared and most of my stuff's already on the left, I'm going to take and just get rid of each of these terms. So the first thing I'm going to get rid of is this x. So I subtract x from one side, but I have to subtract x from the other. But remember, I can only combine like terms. So I can't subtract an x from the negative 7. I can't subtract it from the x squared because these have different variables. I can only subtract it there. So I end up with 4x squared, negative 6 minus 1 would be negative 7x minus 7 equals, and over here I just have a negative 10 because these cancel out. This still isn't equal to 0, so I'm going to make it equal to 0 by getting rid of the 10, and remember I can only combine like terms. So now I end up with 4x squared minus 7x, and then negative 7 plus 10 would be positive 3. Now it's equal to 0. I can identify A, B, and C. And now I can go ahead and calculate my discriminant just as before. So the only trick here is that I have to get it equal to 0. So B squared would be negative 7 squared minus 4 times A is 4 as well, and C is 3. So when I do that, I'm going to get 49 minus 48, which is equal to 1. So my discriminant is 1, and since that's positive, that means I will have 2 real roots, or 2 real solutions, whichever you want to say, and I have found this. So to recap, quadratic can have 2, 1, or 0 real roots, and we're using the equation now to find out which is true, and we use something called the discriminant, b squared minus 4ac. If the discriminant is positive, we're going to have 2 real roots. If it's 0, we have 1 real root, and if the discriminant is negative, there are no real roots. But remember, before you calculate the discriminant, make sure the equation is equal to 0. All right, get some practice in, and good luck.